Alright, let's see an application of the squeeze theorem for evaluating a limit at infinity. So we want to find the limit as x approaches negative infinity of this guy. And if you think about plugging negative infinity in, you could actually get a limit for this, the e to the x part. E to a really big negative number would be getting close to 0. But this guy's kind of weird, right? As x goes to negative infinity, this angle here keeps changing, so the sine wave just keeps oscillating and never approaches anything consistently. So the limit of this guy doesn't exist. So we cannot just think about plugging that really big negative values in to get this limit. Instead, what we do is we notice that there's a sine function here, and we know that the sine of x is always between -1 and 1, regardless of what the angle is here. Okay? And then what we can do is multiply all three sides by e to the x so that we try to get this function in the middle. So that would give us negative e to the x is less than or equal to e to the x sine of x is less than or equal to e to the x. So we have this inequality. So if this is less than this is less than this, then the limit has to apply that way as well. So the limit as x approaches, and we want to be consistent here and say as x approaches negative infinity, of negative e to the x is less than or equal to the limit as x approaches negative infinity of e to the x sine of x is less than or equal to the limit as x approaches negative infinity of e to the x. Well, if we look at this, the limit as x approaches negative infinity, think about really big negative numbers here again. What that's going to do is e to the really big negative number is going to be close to 0, so this negative has no impact on it. So that means this limit is going to be 0. The right hand limit over here, the right side limit, again, as x becomes a really big negative number, e to that power becomes really close to 0. So this limit's also 0. So now we have the limit, what we want to find in the middle here, is bigger than or equal to 0 and less than or equal to 0. Therefore, the limit as x approaches negative infinity of e to the x sine of x has to equal 0 by the squeeze theorem. So we were able to squeeze this function between two functions that have the same limit so that this guy's limit has no choice but to be the same.